All right, let's look at 5.3. 5.3 common factors. Factoring is the reverse of expanding. Common factoring is always the first type of factoring that needs to be completed. So we're always going to always, from here on in, look for a common factor that can explain the following. So let's move on and look at examples. Example 1, you're asked to common factor each of the following. So common factor means we're going to remove the greatest common factor, the GCF, from each part of a polynomial, in this case a binomial. What number can be divided out of both 36 and 12? Yep, that's right, you guessed it. 12 can be divided out of both 36 and 12. So we're going to take out 12. We're going to divide it out. All right, so we're going to divide each term by 12. Now notice it's in green. It's in green because it's not a necessary step. You won't lose any marks by showing it, and you won't gain any marks by showing it. So it's an unnecessary step that you should be able to do in your brain. Once you divide out 12, get 3x minus 1. Now, keep in mind that whatever we get as an answer here, we should be able to get back the original question. Because 12 times 3x is 36x. 12 times minus 1 is minus 12. So what we're doing is unexpanding by looking for the common factor first. 15x minus 25, what can be divided by both of those? That's right, you guessed it, 5. 5 can be pulled out. What will be left? Well, we'll just have to see. 3x minus 5, because both in here we have 15x divided by 5 is 3. 5 times 3x is 15x. 25 divided by 5 is 5, so 5 times minus 5 is going to give us minus 25 when we expand it. All right, moving forward, let's look at some more examples. 12y squared plus 9y. What is the greatest common factor for that? That's right, you guessed it, 3 and a y. A y can be divided by both of these. Now some of you are going, how come I didn't pull out 2? Well, what is the lowest number that I can pull out? How many can I pull out of each of them without going into negatives? And that is, here there are 2 and here there are 1. So I'm going to pull out one of the y's only because that's the lowest number that I can pull. And you're going to pull out a 3 from each term. So we're going to divide each part by 3y. And we're going to get 12 divided by 3 is 4. Y squared divided by y is y. So we have 4y plus 3. Why is it 3? 9 divided by 3 is 3. And the y's are gone out here. Remember again that I should be able to expand it to get my original question, which I do. All right, moving forwards. So again, we divided both by 3y's. You can see here in yellow, it is an unnecessary step. D, 56x squared minus 16x plus 8. Getting harder. What number can be divided by all of these terms? Some of you might be thinking 2. Not large enough. Some of you might be thinking 4. Again, not large enough. That's right, all of these numbers can be divided by 8. So we divide everything by 8, and this is what we get. Take out 8, we get 7x squared. Take out 8 from here, we get minus 2x. And take out 8 from here, we get 1. So we're dividing by 8 by each of these terms to give us this. Again, you can check it always by expanding your answer. And this is in a checking, so here's an example of how you check. You would expand it out. There you go. You do not have to do this. It is not a necessary step. It is just for you to check. So again, this is a check. We are checking our solution here, folks. That's right, checking our solution. So we would cover this. This is not an important step. All right, oops, let's move backwards a sec. Sorry, folks, about that. Let's move backwards and move forwards again. So here we go. That's it. And that's a check. And we move forwards by doing the following. Ready? And here we go. E is 2x times x minus y minus 5 times x minus y. Now, some of you are going, oh, I need to expand. No, I don't want you to touch that way. I want you to look and see what's common. We're supposed to common factor. What is common here and here? Do you see what I see? I see an x minus y. I see the same x minus y here. So what can be done is you can take out the x minus y. What will you be left with? Well, that's right, folks. You'll be left with 2x minus 5. Why? Because I'm taking out the x minus y. I'm essentially removing this piece out, taking out that bracket. What am I left with? Just the 2x. I'm doing again x minus y. Why am I only taking out 1? Because there is only 1 in each of these set of brackets. The remainder is going to be 2x minus 5. All right, let's try F just for a second. Just an easy one to get your brain thinking. What's the greatest common factor? That's right, 2. What are you left with? M plus 2. Let's look at some more examples. G, 40m to the power of 4 plus 35m to the power of 5. How are we going to common factor that? Well, our greatest common factor is going to be m to the power of 4 with a 5 in the front. 40 and 35 have a common factor of 5 m to the power of 4 because there are 4 here and 5 here. The lowest number is 4. What are we left with? Well, we're left with 8 plus 7m. Now remember, the reason we have 8 is 40 divided by 5 is 8. And the 4m's are taken away to have this. 35 divided by 5 is 7. M5 divided by M4, you're going to be left with 1m in the second part. So again, you would just simplify this expression to here. And then if you want to check your answer, you could expand. All right, H, 7x times x minus 5 minus 3 times x minus 5. Now, some of you, again, might be tempted to expand. Don't touch it that way, folks. Remember the instructions. They ask you to common factor. So, how are we going to common factor this? Think carefully. Look on this page already. Maybe look at this example. That's right. X minus 5 is common here. So we are finding a common factor of x minus 5. And what will be left? If I took out x minus 5, so it's this x minus 5 and this x minus 5, we're taking out one of those, we'll be left with 7x minus 3. Again, we take out this x minus 5, we take out this x minus 5, we're left with 7x minus 3 as our second set of brackets. All right, another example, I. Let's look for the greatest common factor here. Well, 6 and 9, the greatest common number is going to be 3, and then x squared and y squared. There are 2 x's here, 4 here, so we're going to take out 2, and for the y, we have 3 here, but only 2 here, so we're going to take out 2 of them. What's left? Well, when I divide out 3x squared y squared by each term, I will end up with 2y minus 3x. And that, folks, is the final answer to that question. Let's look at another example. 64p4 q plus 16p squared q cubed minus 32p cubed q squared. Mind your p's and q's, folks. All right, what do we have to do? Well, we're going to look for the greatest common number that I can divide by all of these. That would be 16. And then we're going to look how many p's, if any, can we take out. Do all of the terms have a p? Well, of course they do. This one has 4, this one has 2, and this one has 3. So now what we need to do is pull out the lowest number. The lowest number is p squared. Next, you're going to look at a q, 3q, 2q. What's the lowest number of q's I can pull out? That'll be 1q. And there it is, folks. I'm going to divide each piece by 1q. So we're left with 4p squared plus q squared minus 2pq as our final answer. All right, some more examples. K. Here we go. What do we do here? Hopefully you see a y plus 2 can be pulled out. What's left? A 4x minus 3. And that would be the final answer that we're looking for, common factor step. L, ax plus ay plus 2x plus 2y, and m, 9x squared plus 15x minus 6x minus 10. Now, a lot of you are going, but wait, there is nothing common each of these terms. And I would say you're probably right. But what we're actually going to do is I'm going to teach you a neat little step about this. We're actually going to partially factor. So only factor in pieces of 2. So ax plus ay is going to be factored as a times x plus y. So again, I'm only looking at these two, the first two here. And so I'm only looking at those, so it's like essentially like covering these up here. And we're going to take out the a, and we're left with x plus y. We do the same for the second piece. So the second piece, I'm going to pull out a plus, always, always, always. Pull out this sign, a plus, and what are we left with? Plus 2 times x plus y. So this is our final answer, x plus y times a plus 2. All right, moving on, forwards, m. Let's do partial factoring for m, this time with numbers, folks. Let's hope you get this. What are we going to do with this is we're going to pull out the greatest common factor in the first two and the greatest common factor in the second two. In the first two, you will see 3x times 3x plus 5. In the second part, we'll see negative 2 times 3x plus 5. And lo and behold, look at this, fancy schmancy, we actually have, do you see what I see? That's right, a common factor of 3x plus 5. So we get 3x plus 5, and what's left is 3x minus 2. All right, that's the end of the video, folks. Have a numerical day. Take care.